Sequences are a list of numbers. There are two well-known types of sequences: arithmetic sequences, which have a common difference, and geometric sequences, which have a common ratio. Here's an example. So you have the sequence 1, 5, 9, 13, 17, 21, and on. This is an arithmetic sequence with a common difference of 4. Here's another example. 1, 4, 16, 64, 256, and on. This is a geometric sequence with a common ratio of 4. Today we'll do arithmetic sequences, and in my next video we'll do geometric. There are also some frequently popped up, sequences that frequently pop up, such as all the even numbers, 2, 4, 6, 8, 10, and on, which have a common common difference of 2, and 1, 3, 5, 7, 9, and on, all the odd numbers, which also have a common difference of 2. Now, who wants to write out an infinite amount of numbers with a common ratio or difference? If you want to, well, wrong answer. Believe it or not, you can write these as functions. There are two ways. Explicit, which is written in the form f of n is equal to f of 1, the first term, plus d, the common difference, times n minus 1, the previous term. And there's recursive. This is, so you have this first term, say f of 1, let's call it that, and that is equal to x. So this is all you need to know. Now you can write your actual recursive function. F of n is equal to f of n minus 1, the previous term, plus the common difference. Now the reason we wrote out f of 1 is equal to x is because we need to know the first term. Because if n, let's say, is 4, then you know that the previous term will be 3. But if n is 1, then the previous term is 0. But what's the 0th term of a sequence? It's like when you're counting cookies, you don't say the 0th cookie, right? It's the first cookie. So it's the same thing here. Alright, so that was a lot to take in. So let's do a couple examples. Write 2, 4, 6, 8, 10, so all the even numbers, in explicit and recursive form. Alright, well, explicit, we'll start off with that. So f of n is equal to f of 1 plus the common difference times n minus 1. Alright, so what's the first term? Well, we can see it's 2. So f of n is equal to 2 plus, the common difference is also 2, times n minus 1. Cool, this is the explicit rule. Now let's do the recursive rule. F of n is equal to, let's remind ourselves what that is, f of n minus 1 plus d. Alright, f of n minus 1 plus the common difference, d, 2. But we also need to write the first term, which is 2. So f of 1 is equal to 2. And this works. Say we plug in the third term. Let's start off with the explicit rule. This becomes f of 3 is equal to 2 plus 2 times, well, 3 is n, 3 minus 1. So that's just 2. 2 times 2, 4 plus 2, 6. Oh, okay, cool, that matches. Now, just to make sure that wasn't just lucky, let's plug in 4. F of 4 is equal to 2 plus 2 times 4 minus 1, so 3. And this becomes 2 plus 6, which is 8. Oh, cool. Cool. We know this works. Just erase that for more space. The recursive rule now. Let's test this out. F of n is equal to f of n minus 1 plus 2, so f of 1, and f of 1 is equal to 2. So again, let's plug in f of 3. F of 3 is equal to f of 2 plus 2. Now this is why recursive rule might be a bit inconvenient. To find f of 3, you're going to have to know f of 1 and f of 2. But thankfully we know f of 1 because it's going to be given. But say you wanted to find the 100th term, then you'll have to find all the previous terms before that, and that's going to take quite a long time. But we can do it over here, since it's only f of 3. F of 3 is equal to f of 2 plus 2. So f of 1 is 2, and the common difference is 2. So that means f of 2 is 4, because 2 plus 2 is 4. And plus 2 is equal to 6. Alright, now let's try f of 4. F of 4 is equal to f of n minus 1, so f of 3 plus 2. F of 3 is 6, plus 2 is equal to 8. And hey, that matches as well. So this works. Let's move on to another problem. Write 1, 3, 5, 7, 9 in explicit and recursive form. So this is all the odd numbers. So let's start off with explicit form again. F of n is equal to f of 1 plus d times n minus 1. Common difference is 2, so f of n is equal to, well, first let's start off with f of 1. F of 1 is 1 plus the common difference 2 times n minus 1. Here we have it. Now we can plug stuff in again. Let's say we want to find the 4th term. F of 4 is equal to 1 plus 2 times 4 minus 1, so 3, which is just 7. Now, say we want to do f of 5, squeeze it in here, is equal to 1 plus 2 times 5 minus 1, 4. So that means f of 5 is equal to 9, and that matches as well. Now let's do our recursive form. F of n, now we can use our previous equation as an example. F of n is equal to the previous term plus common difference. So what's the previous term? F of n minus 1. Now what's the common difference? 2. Now remember, we still need to define our first number. F of 1 is equal to 2. Sorry, f of 1 is equal to 1, not 2. So let's plug in stuff. This is our final equation. Let's see if this works. F of n minus 1, if f is 4, or if n is 4, this becomes f of 3 plus 2. Oh, we still do not know f of 2, nor do we know f of 3, so we need to find that out. So f of 2, well, we can just see what f of 1 is. That's 1. So f of 2 is equal to 1 plus 2, which is 3. So f of 3 is equal to 2 plus, 3 plus 2, which is equal to 5. And now we know what f of 3 is. Now we can see, alright, f of 3 is 5, so f of 4 is equal to 5 plus 2, which is equal to 7, and that is true. So let's move on to another one. Form an explicit and recursive formula given the first term is 3 and the common ratio is 1. Okay, so this is a bit different. We know our first term, f of 1, is equal to 3, and the common difference, messed up when I was writing the problem. Difference. D is 7. So let's write our recursive rule. F of n is equal to the first term, 3, plus d, 7, times n minus 1, which is the previous term. And this is it. Now we can find any term, any number in this sequence. Say we wanted to find the 100th term. Alright, well, f of 100 is equal to 3 plus 7 times 99. 99 times 7 is 63 plus 6, 69. So this is 693. That means f of 100 is equal to 3 plus 693, which is equal to 696. Now let's write our recursive rule. I'll use orange. F of n is equal to the previous term, f of n minus 1, plus your difference. So we know that is 7. We are given f of 1 is equal to 3. So here's our recursive form. Now I'm not going to do f of 100 again because I'd not want to find f of 99, f of 98, f of etc. It's going to take way too long. So I'll just do the third term. F of 3 is equal to f of 2 plus 7. Given that f of 1 is 3, we could just add 7 and we get f of 2 is 10. So f of 3 is equal to 10 plus 7, which is equal to 17. So that's the basics of an arithmetic sequence.